Good morning, everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. And today, in our video lecture series, we are going to discuss about the one of the network theorem that is called Norton's theorem. Come, let's get into the topic. So, Norton theorem, as I said, it is a one among the network theorem. So, this network theorem, Norton theorem, is the theorem we use for solving a given electrical network or a circuit, and it is also known as the circuit theorem. So, Norton theorem is the one of the important network theorem. This theorem is useful for representing the given electric circuit into its equivalent circuit in the simplified form. So Norton theorem states that any two-terminal linear and bilateral network or circuit having multiple independent and dependent sources can be represented in a simplified equivalent circuit known as Norton's equivalent circuit. So as I said, in this Norton simplified circuit, whatever the circuit which is given, that will be converted into a current source parallel to resistance. That current source is called a Norton current, that is IN, and the resistance is called a Norton resistance, that is RN. Sometimes this RN can be called as R Thevenin, RTH, or RE equivalent, and also this Norton current is also called as short circuit current, that is ISH. So here in this Norton equivalent circuit consists of Norton current source IN in parallel with Norton resistance RN. The parallel combination of current source and resistor is a practical current source. Hence we can say the Norton equivalent circuit is a practical current source. So how to convert the complex circuit into a current source and parallel with resistance, which has the Norton theorem has some procedure, some steps to achieve this circuit. So that means it will take more time than normal method for finding the response of an element if the network or circuit having multiple sources and resistance. That time we can use Norton theorem to find response easily. So, as like the Thevenin theorem in the previous video lecture series we have discussed, Thevenin theorem which will be convert any complex network into a voltage source and a series with the resistance. But here only the difference is instead of voltage source we are finding out the current value and parallel resistance. Their series resistance. Here we are going to find the parallel resistance. So now let's see the steps for finding the response of an element when multiple sources and resistance are present in the network or circuit using Norton theorem. The first step one is remove the element where we are supposed to find the response in the circuit. After removal of the element, the terminal will be open. Next step, find the current flowing through the terminal of the circuit obtained in the step 1 after shorting them. The current is known as a short circuit current or Norton equivalent current or Norton's current, that is IN in short format. So replace all the next step 3, replace all the independent sources with their internal resistance in the circuit obtained in the step 1. Next, step 4, find the equivalent resistance across the open circuit terminal of the circuit obtained in the step 3 indirect method if there are no dependent sources. So this will be called as Norton equivalent resistance or Norton resistance, that is called RN. Then step 5, if dependent source are present, then we can find the equivalent resistance across the open circuit terminal of the circuit obtained in the step 3 by using the test source method. In the test source method, we will connect a one voltage source or 1 amp source across open terminal and we can calculate the another parameter current or voltage. We will get the value of Norton resistance R by taking ratio of voltage current across the terminal across the two terminals. So the Norton equivalent circuit as we see in the first slide itself, we have IN and RN. So by following the steps, the steps we the thought in the previous slides, the step 1, step 2 up to step 5, we can finally at the step 6 we can finally convert the complex network into a simplified network like this. So this is the Norton's equivalent circuit, which has IN and RN parallel with each other. And then step 7, if you want to find the load current value, we have to include the load resistance across the AB terminal, and we have to find the load current. So connect the element where we supposed to find the response to the open terminal of the Norton equivalent circuit obtained in the step 6. Step 8, find the response of the element by using laws and basic rules. So Norton's theorem formula is I equal to In into Rn by R plus Rn. And for V equal to In into Rn by R plus Rn. So this is the formula. Thank you.